but this is our second set of exponent rules for monomials. So right here are your actual rules, and you guys were supposed to use those rules to simplify these problems over here. So if y'all are on the back, just go ahead and flip back over here for me. So right here it says a to the negative n. So that means we have a number and it's being raised to a negative exponent. Now whenever we rewrote it, we have 1 over a, and what happened to that exponent? It became positive, okay? So whenever we have negative exponents in math, we don't actually like to write them as negative exponents. We want to rewrite them as positives, and in order to do that, we just have to essentially, we're flipping the fraction, okay? So a to the negative nth moves to the bottom of the fraction, and the exponent becomes positive. So right here, 5 to the negative second power, okay? If we follow this rule, what's going to go on top of our fraction? 1. And then if our 1 is on top, so we are going to move this whole thing to the bottom. So it's going to become 5 to the positive second power. Okay, so I'm not wanting to rewrite things. You guys, some of y'all were trying to calculate them in your calculator. We don't want to do that. We just want to rewrite this in a different way. Okay, so absolutely this is the same thing as 1 over 25, but we just want to still write it as an exponent. Okay, we're just rewriting, reconfiguring things. So x to the negative fourth, what did you guys get? 1 over x to the positive fourth. Very good. So to change it to a positive exponent, we just move it to a denominator. And since this is over 1, we put 1 on top. Okay? All right here, what did y'all get? So what's our first step here? If we have b cubed divided by b to the 9th, we're using our division rule from yesterday. What do we do with our exponents? Subtract. So that's going to give us b to the negative 6, because it's the top exponent minus the bottom exponent. And then we want to rewrite this with a positive exponent. Write all answers with a positive exponent. So b to the negative 6 can be rewritten as 1 over b to the positive 6. So that gives us that positive exponent. So we had 2 steps here. So first we had to divide by subtracting our exponents, and then rewriting it with a positive exponent by making a fraction. Okay? I don't know. Yeah, that's a problem. All right. Nobody can read any of Dylan's handwriting, so. All right, so right here, our next rule is a. This is our power to a power rule. We have a to the m power. That's in parentheses, and it's being raised to the nth power. Okay, it's not being multiplied. You have a power that's being raised to another power. And when that happens, we multiply our exponents. So m times n would be our new exponent. So right here we have 5 to the second power, and this whole thing is being raised to the third power. So our base stays the same. 5 stays the same. And just do 2 times 3 is 6. We're not adding our exponents, we're multiplying. Interesting. 2 times 3 is 6. Okay? The next one, x to the 4th, all being raised to the 5th. What's going to stay the same? X stays the same. And what do I do with that 4 and 5? Multiply. 4 times 5 is 20.
Wait, which one this is?
The one I'm on.
Do the same thing you did for the top. So you put 1 over.
So here we are going to have to do 2 steps here. So the first thing is to do this right here. So what's going to stay the same? The b. The base always stays the same. Negative 2 times 6 gives us negative 12. That's a negative exponent. So now we want to rewrite it as a positive. So we can rewrite this as 1 over b to the positive 12. Okay, so 2 steps here. That was good, Tyler, for seeing that. Okay. The next one, we have a fraction being raised to an exponent. When we have a fraction being raised to an exponent, everybody in this fraction gets this. Okay, so a over b, all to the m power, is the same thing as a to the m power divided by b to the m power. Okay, so right here, if we have this exponent of 2 on the outside, who on the inside gets that 2? 5 and 8, okay? I kind of see this as like the distributive property of exponents, okay? So we have a number outside of our parentheses, and everything inside the parentheses gets that exponent. So this would be 5 squared divided by 8 squared. The 5 gets the exponent, and the 8 gets the exponent. We can't divide this. This is all we can do, okay? Because they have different bases. 5 and 8 are different. Okay. Same here. X and y, x divided by y, there's a 7 on the outside. They both get that 7th power. So x to the 7th divided by y to the 7th. And then our last one, b is already being cubed. So we have b cubed to the 5th power. So what is that going to become? Good, b to the 15th. So we have to multiply these exponents divided by, c is already being squared, also to the 5th power. So that's going to become c to the 10th. We multiply those exponents. Very good, guys. Okay. So same thing applies here. A and b are being multiplied. They are also being raised to the n power. That exponent goes to everything inside the parentheses. So we have 5x squared, all being raised to the 2nd power. So we're going to do 5 to the 2nd power. What's 5 squared? 25. We're actually going to square that. Okay? Because you see how this is a coefficient now? It's attached to variables. So we actually want to square it this time. We didn't want to square the 5 here because there were no variables. Okay, so that's one of those weird things where we actually square it this time. X squared raised to the 2nd power becomes x to the 4th. XY squared all to the 6th becomes x to the 6th, y to the 12th. We can multiply those exponents. Everybody inside the parentheses gets them. All right. 4x squared y to the 4th, all being raised to that 3rd power. Again, we are distributing this outside exponent to everything inside. So we're going to do 4 cubed. What is 4 cubed? 64. So we actually calculate that one when it's with other variables. Good. X to the 6th because 2 times 3 is 6, and y to the...
Wait, so you do with the one that's like attached to it, not the one outside the parentheses?
Say that again.
When you're gonna do power, you do the one inside the parentheses, not outside?
So are you talking about my 64?
Yes.
Okay, so the 4 is inside the parentheses.
Mm-hmm.
The exponent out, 3 is outside. Okay, so since this 4 is attached to variables, it's a coefficient. So we're actually going to raise that to that 3rd power, and 4 cubed is 64.
Okay.
And then you give that cube to everybody else as well. If I just have a, like on here, right here, 5 to the 6th power, I don't want to calculate that one out because there are no variables. We want to keep an exponent. Okay. Anything to the 0 power is 1. 5 to the 0 power is 1. X to the 0 power is 3. X squared, y to the 5th, all to the 0 power is 1. Guys, this is like the most helpful rule ever, and a lot of people miss it. Guys, everything's 1 when it's to the 0 power.
It doesn't matter if it has like the biggest number.